We're busting out the calculator to give us an idea of how to enter data in the calculator and use it. It's a powerful tool. We want the least squares regression line, not just the line of best fit, but the line of best fit. There's our data about the snowpack from the other thing. Here's our home screen of the calculator. If you want to clear stuff out, you just hit clear, it clears it out. We're going to need to go to y equals, the equation editor, where we can type stuff in. I'm going to clear out that equation, so I just hit clear. We're going to get used to these scatter plots. You can see plot 1 and plot 2 are on. The stat plots are above the equation editor as a secondary function. Now I want to get plot 2 off, and I might as well get all the plots off so I can start over. I hit option 4, plots off. So I can type in a 4, it takes me back to the home screen. I hit enter and it's done. My plots are off. I'm going to clear this out again. Now I go to second stat plot. I go up to the plots again. I'm going into plot 1 and I'm going to turn that thing on. And so everything's going to get set. What this is, we'll need to set this this graph right here. If the graph was originally set on a box plot or something like that, we'll get the cursor here and set it back over to scatter plot. That's the very first type of graph. Hit enter and it's selected. It will ask you what your X list and Y list will be. We're going to leave that as list 1 and list 2. Let's suppose you got on your calculator and it was list 3 and you don't want it to be list 3. All you have to do is get your cursor on top of that list 3 and replace it with list 1, where you will find as a secondary function above the number 1 key. So we'll go second, L1, and hit enter. Everything is set up for us to look at the graph now, and we'll get back to that later. If we're doing something involving statistics, which we are, regression line is statistics, then we are going to go to the stat menu. So we will get used to going to stat. Edit, there's an edit menu, a calc menu, which we'll use after we edit the data to calculate the least squares regression line, but for now we have to edit the data. So we just type a 1, and here's our data. Now that's not the data we want, that's the data we want. So we need to clear out the list. Get in the habit of getting your cursor on top of the list that you want to clear out and hit clear and enter. So I want to be very clear about this. We use that button a lot. Let's go over to this list. You got to get the cursor on top of the list, not on the first space where it is now, in order to clear out the data. So let's go up arrow. Now the cursor's on list 2. We hit clear and enter. And now we have the lists 1 and 2 are available for us to enter our data. We go into list 1 and these are the days, 0 through 50 going by 10. Hit a 0, hit enter, hit 10, hit enter. We're going to type in all the X coordinates of the days for which we have collected data, namely the snowfall, and we're going to put this into list 1. So when we're done, there's our list 1. I see that I made a boo-boo. I only have a 1 instead of a 10, so I'm going to go up here and make this a 10 and hit enter, and now everything looks good. I go to my Y list. I have to put the collected snowfall that we had on those specific dates. My first Y value is 35 and 52, so we enter the data like this, going down through the list. Now, if you recall, we ended up with the freehand line of best fit. I admitted that I didn't like my line of best fit on the other video when I did it, and that's because I'm relying on my vision, which isn't very good, to go through the scatter plot, to go through the graph and try to find the line of best fit. This is the way to get the line of best fit. All right, here we go. Got our data, we got our ordered pairs in list 1 and list 2. Now we want the calculator to calculate something statistical. So we go to the stat menu. These calculators are very user-friendly. If you put the effort in, within a day, you'll be real comfortable with where we keep going for this. We're done with the edit menu. That's where we put the data. We need to go to the calc menu, hit the right arrow so we can calculate something. And we're going to calculate this guy, number 4, linear regression in the form AX plus B or MX plus B. Later, when we get to be bigger kids, we're going to go to statistics, the stat class. We're actually going to use the form y-intercept plus the linear term. For now, we don't care. We're going option 4, the linear regression model. So we type in a 4. So now this is the cool part. Is your X list in list 1? Yep. Is your Y list in list 2? Bet your sweet bippy. Leave the frequency list blank, and let's go all the way down to calculate. And what the calculator will do for us is it will give us the equation and A is the slope and B is the y-intercept. You know that because right up above it, it tells you y equals ax plus b. So you can write your equation down. We now know the equation based off the calculator is 1.91x plus 35.4. Okay, and now let's stop and think about that. That's a line. That's the y-intercept. That means our prediction when it's 0 days after December 21st is that we have 35.4 inches of snow. Hey, we had 35, so that seems like a pretty good estimate. Here's our slope. We remember that slope is the change in y over the change in x. Our y variable is snowpack in inches. So we're saying, oh, our slope says that we're getting 1.91 inches of snow for every 1 day we go past the 21st of December, past the beginning of winter. So slope makes sense, and if you recall, my slope was 1.6, pretty bad when I did it by hand. This is accurate. This is the line of best fit, known as the least squares regression line. We might look at the R value right now. It's 0.997. The R is called the correlation coefficient. The closer it is to 1, the more perfectly these points follow this line of best fit. If you had an R value that was negative 0.99, that simply implies that your slope is negative. Like in the spring, how is the snow melting? That's going to have a negative slope, like maybe negative 1.91 inches of snowpack per day. Then you're going to get a correlation coefficient that's negative. So we'll talk more about correlation and correlation coefficients later. Just a couple last things to do. Do you remember that we wanted to see our scatter plot? We turned our scatter plot 1 on, and we would like to see the graph, these points with the line of best fit on them. And so by turning that stat plot on and making sure that there's no equations left here, our window might be set really strange. You might have used these calculators before. Right now our window is set where x min is at 2 days and x max is 98 days. Y min is 0.655 inches and Y max is 2.7. We wouldn't see our graph of our points if we use this window. We don't even have to set the window. When we're doing a line of best fit, these calculators are awesome. We're going to the zoom button right here. If we do zoom and then we choose option 9, which is stat, the calculator will zoom in on the stat plot that we entered. So we go zoom 9, and there you go. It gives us our points. If we hit trace, it'll tell us, hey look, this is the point 035. That was our first piece of data. Hit the right arrow, that's 10 and 52. After 10 days we had 52 inches of snowpack. Last thing we want to do, in addition to putting this on here, is to go to y equals and enter our equation. There's simpler ways to do this, but what the heck, let's just type this in. We type in 1.91x, and we add to that the 35.4, and we hit enter. Now we have our equation in the equation editor. Now if we hit graph, it will graph our line, and it will show our line going through those data points. So we can see that the points are strongly correlated. They have a strong linear association, and the slope is positive, so it's a strong positive linear association as opposed to a strong negative linear association. You can turn the video off now if you want to, but let me show you one more little trick. Up above graph, there's table. We can go second table, and if we set this thing up correctly, then what we can do, since we have our equation right here entered into the equation editor, we could say, you know what, I want to know how deep the snow is expected to be on like day 84. Well, 84 is the x value. You can just type in an 84 and hit enter, and it will automatically give you the y value, the depth of the snowpack, according to our equation. You don't actually have to type in the numbers yourself in the equation. So this is a time saver. You can, as long as your equation is entered in y1, you can do that. For you to get that to show up on your calculator like that, simply go to table set above window, second table set, and don't even worry about the first parts. Just make sure that the independent variable is on ask, hit select, hit enter, and then every time you go back to the table, you'll just be able to enter, hey, I want to know the snowpack on day, let's say 140, and we type in a 140, we'd predict 302 inches. One more thing we should say though is it appropriate to go to day 140? Well, it's really not, because our data was only collected up through 50 days. And we know it's not realistic that we're going to keep getting colder and colder and colder, because winter will end and spring will come. So the reason we got such a wacky answer of 302 inches is we typed in 140. That's called extrapolation. Extrapolation's bad. We went way beyond the data that we had collected. But anyway, that is it. That's how you do the regression. If you want to go back through the video and look at those steps again, you should, until you get them down.